All right, thank you for joining us. So we're talking about progressive delivery today. Do you like the background? So I was looking for a cool picture of Bucharest, of Romania, and I found this one, and I thought it was pretty appropriate, you know, with the moving lights and everything. And then I arrived here the other day, and I was like, oh, this looks really familiar. So yeah, that's funny. Um, all right, so maybe we'll start with introducing ourselves.
Thank you. Thank you very much. So this guy with the super nice hat here, it's me. My name is Natale Vinto. I'm a developer advocate. I'm in great company with my teammate Kevin and my friend and mate Daniel, which is a great developer advocate. So you have the Gotha of developer advocacy here, right? Yeah, so what we do, what our team do is helping communities and customers having success with their Kubernetes and cloud native strategy. I'm a Free Software Foundation Europe member, supporter, blues addicted, and coffee addicted. I hope you had your espresso shot. And talking about espresso, we have a web TV show called OpenShift TV Coffee Break, bi-weekly on Wednesday, 11 a.m. your time. If you are interested to listen about Kubernetes architecture, we're live on OpenShift TV. Those are the two books I wrote for O'Reilly, Modernizing Enterprise Java and GitOps Cookbook. You find the link to download for free those books in the slide afterwards. Thank you, Kevin. Do you want to go?
Sure, yeah. So, and I'm Kevin Dubois. I'm also in the developer advocacy team, of course. I've been in the software industry about 18 years, I think. And I really like...
18 years, wow. How old are you, man?
I know, I'm old, I guess.
So old, this guy.
Nice, thank you. Yeah, and I'm really passionate about improving the developer experience, you know, making it fun to develop code, and not just developing code, but also what happens afterwards, right? Once our code goes to production, how we can improve that process and make sure that everything works as well as it can, and ideally with open source. So we work at Red Hat, so we're lucky enough that everything we do is open source. But yeah, so that's what we like. If you want to follow us or follow me, I'm on Twitter, Mastodon, and I have a few thingies on YouTube and LinkedIn. You can whatever connect. I'll put the slides on my Twitter account, so if you want to have the slides afterwards, but we'll send that link afterwards. So on the agenda today, so we're going to be talking, of course, about progressive delivery because it's in the title. And do you like the Romanian colors, by the way? So we'll first talk about continuous delivery as kind of the precursor of progressive delivery. We'll talk about what is progressive delivery. We'll talk about some techniques of how to deliver. We'll talk about and we'll show you how it works in practice. And then we'll also, as the final hurrah, hopefully, we'll do a delivery based on metrics where it's going to roll out our application and look at what the metrics are like. If there's errors, then it's going to automatically roll back. But we'll get into that a little more as to how that works and why we want to do that. We can skip over that one, and I'll hand it over to you for now.
A quick introduction about the context. We're talking about developer flow. So this is what we call the transition from a development phase called inner loop, where developers code, build the artifact, and the package, eventually, hopefully they test the software, and then there's the debug phase, and then finally pushing this artifact somewhere. The artifact can be a jar file or a container image. And then we move into the outer loop, so where your code is really deployed into production. The outer loop is where automation happens. So after the developer finished the inner loop cycle, it starts the outer loop. So with building from pipelines. You can see the logo of an popular open source project called Tecton, which implements Kubernetes native pipeline. We will see in the demo how it works. Hopefully compliancy, security, and integration test. And then finally you can deploy. And in the deploying phase, we call it the extended CD with GitOps approach. We're gonna dig a little bit more into GitOps. What is GitOps? But as you can see, you move from a development phase to a deployment phase, and this deployment phase is managed by the GitOps approach. This nice icon you see here, this pulp is ArgoCD, a very popular open source project implementing GitOps. We're going to show in the demo how it works. So that was the, already said that, so we can skip this slide. I want to show this, that this slide is very powerful, and I'll make sure you can see that. So we moved from a traditional model of development, right? From a monolithic application containing everything inside, with a single database, eventually with lots of schema, to a microservice-based architecture. So the transition from monolith to microservices is still going on, but we can say that microservices today are mature technology, containers is the major technology, and this mesh of service that you can see here, they are all connected and they belong to a certain pipeline. So each microservice has its own pipeline to produce an artifact, to move from that inner loop to the outer loop. And also the database changes because you don't have one single database. You may have multiple databases with multiple schema. So we're moving from a release cycle of months to a release cycle of week, days, or even hour. And in the demo, I think it's 2 minutes or 3. Let's see. Let's see how it goes. Let's see how it goes. We want to show you this live with you. So we're going to play a game to make it more fun and interactive, right? This is the game we will show you. So we will ask you to use your phone to scan a QR code, and you will access the front end of this game. This game is a Java Quarkus app deployed on OpenShift, which is a Red Hat Enterprise version. We will also handle a dashboard for this game. And the purpose of this game is really make a electric car competition. So you're gonna randomly divide it into 2 teams, and you have to move those cars by tapping your screen. And we'll see what happens. We have some swag here. You're gonna win some prize, so please put some energy because we need to provide some good green energy, right? So I think this is the explanation. I wanna go into the architecture before we go into the demo itself. Why we're doing this demo to you? Because we want to show you how it could be a microservice-based architecture, also event-driven, and how we use GitOps to create that automation, that outer loop, that deploy our new version of the game. So in the first, this game is just a client that connects somewhere, and we're using, the backend is using Infinispan, which is an open source project for distributed cache sessions. And we're using also Kafka, very popular, data streaming open source project to send streams, to exchange data between microservices or between other entities. So the game is compiled by a admin dashboard and the client, and you're gonna interact with the client. And we're gonna show in the video the dashboard. We want to show you this because we want to show you how we move from the inner to outer loop in all automated way, right? We're going to have a version 1, and then we're going to move to a version 2. So let's start the game. You have to go here and press and see this QR code. I'm hoping you can access it. So what you should see right now, let me check also live, Kevin. You should see a screen like the one you see in the slide, where there's a car rotating and a name on top. So this is your nickname, randomly assigned. And we're dividing you into 2 teams, team 1 or team 2. Let's give some time to the team to be created. And I want you to be really, really competitive here, right, Kevin?
Yes.
Because
this is serious, guys, okay?
Yeah, you're gonna win some swag, but let me tell you this. If you are assigned to a team and you don't play hard, you're gonna affect the performance of the whole team. This is a weighted, it's kind of weighted mechanism, so everyone is in charge here.
And we can see who was the one who wasn't tapping at the end.
Yes,
so.
exactly. Yeah. So if you have all this kind of screen, please confirm you have all the screen. How many people in team 1? Okay. Oh, wow. How many people on team 2? Oh, wow.
Okay.
This random assignation works.
So now we have to go to the dashboard.
Yeah, let's go to the dashboard.
So it's right there.
Right on. So this is the dashboard. Kevin, I think we need to refresh the dashboard because the WebSocket, blah, 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 needs some refresh. And I hope the Wi-Fi works fine. Otherwise, we're not performing very good the game.
Be a fun game.
Let's give some time for the Wi-Fi to react. Yeah, we lost the session. Let's log in again. Hey, Kevin, in the while, I want to show you this. I want to show the dashboard, right? So team 1, team 2. You're not gonna see all the team member, but if you recognize you in those teams, 26 people in team 1, 29 in team 2. Those are randomly assigned. Now, before starting everything, I want to show here, Kevin, how this is made. So you can see here, this is OpenShift, which is a Red Hat Enterprise version of Kubernetes. And we deployed this app in Quarkus. Quarkus is a very popular open source project for performant Java application. You have here one of the greatest representatives of Quarkus community, which is Daniel. Any question about Quarkus, there's Daniel responding to those questions. And this app is using a framework called Quinoa. Quinoa is an open source framework that lets you add the front-end JavaScript on top of Java app. So this app is our game, and it's an available game. So this is in production, right? It's a 5 replica, super available, fantastic. We have an InfiniSpan cache, and then we have a Kafka cluster. We created this Kafka cluster into OpenShift in a kind of a self-serve way by ordering the Kafka, ordering the InfiniSpan. So everything is here. Everything is ready to start. And now, folks, I think it's time to go.
Everybody ready?
Ready? As soon as I press start, and I hope you can see the start here, you should see a windmill in your phone. Go. Please go. Go, 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 go. Go, 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 go. So, Kevin, which member you are?
I didn't play.
No, you have to play.
I didn't want to let the team down.
No, you have to play. Tap it, tap it, tap it. Tap it, Kevin. Tap it, tap it. Yes! Congrats! Congrats to team 1. So,
team won the game.
Team. We want to be fair here.
Yeah.
So the font size was too big that we haven't shown. But this is team 1. And I want to send my congrats to MacGoff. Who is MacGoff? Who is MacGoff here?
So
generating
phone,
so much energy. Thank you. You're the greatest. The daughters, Hickling, Toyoma. This is a kind of a fair ranking in general, but Team 1 won. So thank you, Team 1. But
don't worry, Team 2. You'll get your revenge. Okay, you can still win the next one.
We give you your revenge. We give you the chance to win those fantastic swags over here. Kevin, I think we gotta go back to our flow because we show the fun game. Okay, there's Kafka, InfiniSpan, Quarkus, all good. But now let's go to the main point, right? What if we need to add a new feature, Kevin? What about it's Friday, 5 p.m., and the developers say, oh, I want to add a new feature. And the ops say, what? I got to go home, and it's Friday. Come on.
I know. We almost had the time right here.
You remember that diagram before. So the monolith months of release cycle, the microservice-based, the new Kubernetes-based application architecture, week, days, minutes or seconds. It depends on the speed. So we want to show here when you adopt the GitOps approach, you are more keen to accept those last-minute requests like the developers doing right now because there are in place all those tests, security, compliance that you can all automate. And when you implemented a new feature in your system, this is something that might happen, right? So we want to avoid the disaster recovery kind of stuff. We want to go into the details. Now, before we go into the GitOps part, right? We want to share also with you the source code of this app. And we want to show you that when you GitOpsify your project, you have at least 2 source code. One is the source code of the app. You see the source code of the app here on your left. And there is another source code, which is the source code of the manifest. So not only the source code of the app, you have the source code of the Kubernetes manifest describing this application. GitOps is an agnostic approach, so it shouldn't be only Kubernetes, right? But in this case, this is a Kubernetes app, so the manifest describing your app are in this repository. So if you click here, you're going to see the source code of the app, source code of the repository. We're going to go into the details while we run the second part of the demo, because now it's time to deploy a new feature in a GitOps way. And Kevin,
we first have to develop it.
Yeah, please, developer, go, and I'm gonna develop your stuff.
All right, so I'm just going to go to GitHub, and I'm going to go to edit.
Which feature you want to add? At Friday.
All right, so what I want to do is, instead of tapping, it's kind of annoying, I want to make it more real, you know, because we're creating energy for a moving car, right? So instead of tapping, why don't we use the gyrometer of our phone and shake to really create energy, okay? So that's what we're going to do. So I'm developing...
Dangerous feature, but funny.
So I'm going to do hardcore development here. I'm going to go and, I guess I need to edit it. Directly on GitHub, right? Because that's how we develop these days. Oops, false.
Don't worry, all the tests are in the pipeline, so it's fine. You can destroy it.
Impressed with my development skills? All right. Change to shaking. Commit directly to the main branch, right? Because that's also what we do. No problem. All right, so now we have, you know, I guess we go back to our OpenShift. So there's a feature in OpenShift, so it's basically, OpenShift is Kubernetes, right? And so there's a Kubernetes project called Tekton, which allows you to run pipelines on Kubernetes very easily. And for every step, you know, like a Git clone or, you know, Maven build or whatever, so for every step, it's going to create a container, do its work, and then it's going to tear it down. So it does that automatically. So you just declare a manifest, basically, the steps of your pipeline. And based on that definition, you do your pipeline. So in this case, you can see it's running because there was a webhook. So when I commit something, it's going to automatically, of course, kick off my pipeline. It's going to run through a bunch of tests. Not really in this case, but but so, you know.
Ideally, I say hopefully.
Yeah, exactly. And so we'll build the application. Then it's going to create a container image, and it's going to push it to a Quay repository. So Quay is like Docker Hub kind of thing.
Well, we have the integration test here. At least.
Oh, yeah, we do. And then once that image has been pushed to Quay, we're also going to update our manifests, right? That ArgoCD. So ArgoCD, and maybe we'll explain that in a little bit, but it's going to be monitoring for changes, right? And so it's going to notice like, hey, you've updated the tag of this image, so now we need to do a redeploy of the application. So it's going to go all automatically. So in this case, you know, of course, the Maven build is going to take a while, but I'll let Natale explain a little bit more about GitOps. Oh, we lost the click. Oh, there it is.
Yeah, let's go into the GitOps methodology in general. So if you remember, we had the inner loop. So at some point, we did this change. Kevin, you had to test it a little bit, but we went through. And there is the outer loop, that there is the pipeline that you've seen. At some point, there's also this part, the deployment phase with ArgoCD. We will also show that in a moment. So your production, most of the time, right? It's Kubernetes. In this case, it's OpenShift, but most of the time it's Kubernetes, right? And what we want to show that you can do this continuous loop from the inner loop to the outer loop with GitOps. But what is GitOps? How many people knows about GitOps? Oh, fair enough. Yeah, because our title attracted them, of course. Otherwise, they weren't there. But how many people use GitOps in production? Oh, wow. Oh. Brave. You're the guy. Right on. Now, we want to inspire also you encourage you in using GitOps. But what is ultimately GitOps? I think it's composition of three main pillars. The first pillar is a methodology, right? It's an approach. This methodology says that for the first pillar, that Git is the single source of truth. So everything that is in Git, it's really what the reality should be. It's also a declarative way to define the infrastructure and a declarative way to define how your application should behave. Second thing, you treat everything as a code, not only the app source code, if you remember. We had the source code of the manifest describing this app. So it's infrastructure as a code, it's security as a code, it's policy as a code, configuration as a code, everything as a code. And every operation is made through a Git workflow. This means that you make a change, it's you do this change on Git. You need something to review, it's a pull request. So when you need to change something in production, it should be a Git action. It should be a Git workflow. And hopefully there should be some review, so you can review your change beforehand, apply more important rollback in it if everything goes fine. If you remember the change on Friday, if everything goes fine, we need to be able to roll back. And GitOps implementation allow to do that. There are two main phases. So from the source code app, you move into a CI part. We have seen it with Tecton and OpenShift pipeline in that case. So you create the golden image or the golden artifact, and you store this image containing your app into a container image registry. This is the CI world. Let's go into what we call this extended CD world. A Git workflow, a pull request, a Git commit and push on the manifest of the repository of the manifest describing this app will update the deployment of this app somewhere. And this CD loop that you can see here, this is the GitOps controller, is an object that will either push into the cluster the new change, but also pulling from the cluster anything. So if you have done something on the cluster which is not on Git, that is not allowed. You are violating the approach, the paradigm. So this tool is gonna roll back your change. So it's also a powerful tool to have an immutable production infrastructure and environment. Blah, 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 it's time to play. Now...
Maybe we should show first that it was deployed.
1 second, because I want first, Kevin, I want to stop here because, we have to stop the session, otherwise it's gonna complain, and then let's go into the flow. So the CI part here terminated, and let's see the CD part. The CD part is managed, as we mentioned, by ArgoCD, very popular open source GitOps project. And this project is gonna, you can handle many apps. In this case, where this app name is Wind Turbine. As you can see from the ArgoCD dashboard, this tool is putting in sync all the object for this project. So we have a deployment, Kubernetes deployment, Kubernetes service. As you can see, as soon ArgoCD retrieve, there's a change on Git, and we will see who made this change on Git. In this case, is the pipeline that performed a change on the repository representing this application. The pipeline here is using another open source tool called Customize. It's an open source tool used in Kubernetes in order to have different configuration of your app. So Customize here is just changing the hash of the container image representing version 2 of our app. So the pipeline did this automatically. You can also put some review here, some opening, some pull requests for more extended review phase. But this is the thing, and I want to show you, Kevin, also how it's made. So this manifest repository, we basically put into the source code, the Kubernetes deployment, the Kubernetes service, a route in this case for exposing the traffic outside, and this file called a customization file, which will track all these resources and then apply a delta, apply a change to this file. In this case, we're changing the container image hash in our project. Now, let's go let's see. So everything looks fine in terms, of apply. I see a commit, I see an apply. I see pods are still updating. So let's see if our rolling update has finished. And this is important. When you change something in production, you don't want to give service interruption, right? You want to give a nice experience where the new version is available only when it's ready. So hopefully we have some health check configured in this app. And when the new version is ready, then Kubernetes will serve the traffic to the new version. Kevin, to me, this looks fine. So let me go back and verify if that works. For those of you that have not already done it, when you go here, now you should see kind of warning or just a banner say, hey, enable shaking. Moreover, on iOS, you should allow this feature like it's a permission. Well, you need to allow the access to the accelerometer. Yeah,
that sounds about right.
But once you've done, click on enable shaking. And when you click on enable shaking, it means that the shaking is enabled. So the version 2 that Kevin enabled in 1 minute and the pipeline did in 2 minutes with all the tests and the cache is done. Please.
One question here. Why is not the first window refreshing with the new application version?
So you had the whole version and it didn't refresh it. Yeah, that's a good point. We haven't put the JavaScript loop to auto refresh the page for this demo.
So you have to like manually refresh.
Yeah. But hey.
Okay,
yeah.
Sorry, I thought that I refreshed it, but
Okay.
You did it manually, it didn't work?
I thought that no.
Okay. But hey, open source also demo, pull request very welcome. We are keen to accept this feature because the auto refresh would be really, really nice. So thank you for that. So now, Kevin, it's time to play for version 2. Version 2 is shaking. Now, let's go into our dashboard.
Before we start the game, please hang on to your phone because it can fly away.
Yeah. Let me refresh the session, Kevin, because I know that our session are kind of short, and this is another pull request we can make.
Right.
So team 1 and team 2, those are, again, randomly assigned. It could be that you are now team 2, and before you were team 2, it's random. It's a feature. It's not a bug, let's say. And then now you have your shaking enabled. Like Kevin was saying, don't throw the phone in the head of the person in front of you.
Unless there's somebody you really don't like, and it's like, oh, oops, sorry, didn't mean to.
So this is the time now to win those fantastic swag. So we have 4 books here about OpenShift for developers and the path to GitOps. And now we have a polo and some beautiful socks from Red Hat developers. So it's time to win all those stuff. Please focus. We need to win, okay? Daniel, you are out of this game, of course, because so don't try to do bribery. We cannot. Okay, ready? 3. Oh, we have also the music. 2.
Nice.
1. Go. Oh, I like the music. Come on. I'm always team 1. Yes! Team 1 won. Congratulations, everyone. So, congrats, team 1. Fantastic game. Everyone safe? Everyone is safe here? Fantastic. So, who is team 1? Congrats, folks. Congrats. And congrats also to team 2. And you can see here the overall leaderboard. So we're gonna do the prize. We're safe.
Yeah,
no, we're fair.
I'm noticing that the best player was not on team 1.
Exactly.
Nice.
So our respect is for team 1 members, but we have to give the prizes to the overall leaderboard. So who is Melko? Melko, come here.
Nice.
Or I can go here. Congrats, Melko. pick one of these.
It's the same?
Yeah.
I'd say this one.
Okay, congrats. So, Melko done. Thank you, Melko. Who is Gritzel? I'm going to come to you. Gritzel, pick one of these fantastic books from Red Hat developer. Pick one of these.
Which one do you recommend?
This one is very good. Yeah. Also this one. So, who is, let me check. Hole. Who is Hole? Hole. And then who is Iklin? Iklin? Yeah, fantastic. Great. Fantastic.
Quick question, is everybody okay? I was making a little video. Is everybody okay if I put that on Twitter? If anybody's objecting?
How many,
okay,
how many stuff we have there? Huh?
3.
3?
Yep.
4. So who is Gerardi, Meggoff, Almendaritz, and KW? Raise your hand because I forgot who you are. So please take the fantastic sock from Red Hat developer. Incredible stuff. You? Who is the other winner? Oh yeah. Done. Okay, thank you very much. This was an interactive way to let you engage with GitOps. But now, Kevin, we're going to go forward.
Yeah.
It's not the only way to do deployment, application deployment. Actually, there's a smarter, subtle way, no? More
Exactly.
granular way.
Yeah. Because in this case, we still had like some risk, right? Because we did a big bang release of the entire code at once, and which in this case was fine because everybody wanted to shake. Of course, nobody wanted to tap anymore. But let's see, how we can do the releases even better using GitOps, but also using some other tools. So we're going to be talking about progressive delivery. And so, as you can see here, step by step, and that's kind of the idea of progressive delivery. So what is progressive delivery? So we first have, we talked about continuous integration and continuous delivery, and that gets us, pretty far in our release cycle. But so what is progressive delivery? So progressive delivery means you're not doing big bang releases all at once. I mean, you can, but the idea is that you do it progressively, step by step. You release maybe, to a subset of users or a certain percentage, and then you see, how is it behaving under these circumstances, and then you can release it some more. And so the concept is with progressive delivery is that you don't necessarily call deploy a release. So you can deploy to production, but you're not actually releasing to production. You're deploying it, but you're not sending your end users to this new version yet, right? So you're going to have control over how you're going to do that. And we're going to do that based ideally on metrics to see, who's, are there any issues? Are there any errors? Are there features missing? We can test it ourselves maybe. And so we can have more control over that. And so, for example, we can do it to a subset of users. Why do we want to use progressive delivery? Of course, the ideal scenario is to decrease downtime, right? I mean, if we release everything at once, it means that if something goes wrong and we have to roll back, then then we have downtime. We have issues during that window where the new version was released. So it limits the tragedy of, oh man, now Friday night, I have to work all night long and I was going to party. Ideally, we're not running into those kinds of tragedies. And of course, we want to deploy faster and without too much risk to production, so we can release our new features with more confidence and hopefully beat our competition. And then who was in the closing keynote yesterday? Okay, I was I was hoping more, but we were talking about mocking, and that's maybe not always the best idea to be doing a lot of mocking. Well, why not just test on production, right? And then you don't have to do as much mocking, of course. All kind of depends. And you don't have unreliable fake services that you're setting up even in other environments. So ideally, you can test on production. And this was a picture I took yesterday during the keynote. The actual production code has 4 lines, but now we have to create all these mocks to be able to reproduce the scenario. So again, if we can have a better way of doing that. So first, we'll talk about some delivery techniques, right? So deliver. So the first one that most people probably are somewhat familiar with is blue-green deployment. So blue-green deployment basically means I'm releasing my new version, my green service. I'm still sending my traffic to the first version. I'm going to release it. I can see that the configuration is correct. And then once the configuration is good, then I'm going to send traffic to my other version, and then the blue service can go away if everything goes well, or I can roll back pretty quickly by just switching the service back to the other version. So that works pretty well. But there's another way of releasing with canary releases where you can actually have a little more control over how you're rolling out. So in this case, for example, we're starting with 10% that goes to our newer service. We're going to see how that behaves. And then, if everything goes well, then we can release it more. And so that's called a canary release. Then you also have this concept of dark launches, where there's a few different ways of doing dark launches and different reasons why you might want to do that. One is mirroring traffic. So in that scenario, you're going to release the new version, our green service here. We're going to send the traffic of the end user still to our first version, but we're actually going to duplicate the requests to our new version. So we can really see how it's behaving on production without your users actually being affected if there's an issue. So that's a nice use case. Of course, depends on what kind of state you have behind it, right? I mean, you have to be careful of that with all these scenarios. But it is kind of nice to be able to see, how's it going to behave under load. And what you can also do is, use, for example, feature flags, or you can use certain user agents and then pass those in and say, and this service is going to decide, hey, this particular match test equals true, so I'm going to send traffic to that one. So maybe your employees can test a new service where all your customers are still using the previous service. So those are different techniques of releasing, of deploying your application and seeing how that all works. Now, we're going to be basically testing on production, right? So don't tell your manager. But really, production in that case is not sacred anymore. We can actually use production as a phase in our testing. Should we do all our testing there? Probably not, but we can do some real-life testing. And I put that again there because, well, I remember earlier in my career that we also did testing on production because, we didn't have automation back then, or not as much, and so basically the only time you would really know how your application was going to work was on production.
And you were using FTP, right?
Oh, probably. Well, what was interesting about that is that means you're going to have downtime, probably. So we had to have windows where, in those windows we would put our site offline, and then we would release our code and everything. So we did test on production, but it wasn't ideal, right? We want to be able to have always available services. So yesterday, Victor was also talking about the testing pyramid. And so in this case, this is, well, it's not a pyramid at all, but you have to use your imagination a little bit, okay? So before we release, before we deploy, we're going to be doing, the usual testing. We still need to do unit testing. Sorry, guys. We still need to do, make sure we have enough code coverage, doing contract testing, mutation testing, and all that stuff. But then we can deploy. And so this is part of the testing on production. We can deploy to production, do certain integration tests that perhaps are really difficult to do in other environments. We can do load testing on our real production environment. We can do shadowing, like I was talking about, right? So splitting the traffic, but not really having the users being affected. And then once we release, doing canary releases or whatever, we can do monitoring, we can do feature flagging, and feature graduation to see, like here is our new version, and we can send some new traffic to that. And then eventually, of course, ideally, have all our traffic go into there. But it doesn't end there, right? Even after we release, we need to continue to do, certain tests, and we definitely need to continue doing our monitoring, right, to see, like how is it behaving even after we release. Maybe there's still things that we need to adjust, and then we can quickly iterate thanks to progressive delivery because we have confidence that we can release new features in a controlled manner. Okay. That's kind of the idea behind progressive delivery. So how do we do that? Outside of Kubernetes, you can, but it's complicated, and I don't know exactly like what the best way is. But Kubernetes helps a lot with those kinds of scenarios, right? Because it has control over how to deploy, how many instances to deploy, and everything. So that makes life a lot easier. So that's what we're going to be talking about. And when we talk about Kubernetes, inevitably we have YAML, right? So yeah, we'll show. Yeah, sorry, it's not maybe visible to everybody, but we have here a service. So in Kubernetes, a service basically manages where traffic goes to which pods and which deployments. And we have this. In this case, we have just using Kubernetes, we can do some sort of progressive delivery. So in this case, we can do a blue-green deployment with Kubernetes by having a selector, which basically sends traffic to matching pods that have a specific label, right? And so we have a deployment, and then we match it up with Kubernetes labels, and that's going to send traffic to one service or to another service. So we can flip pretty easily. If we deploy a new service with a new version, we just have a new label, and then we set the new label for the service, or match it with the service, and so we can switch the traffic. We can do also canary releases with Kubernetes. Again, using different services or the same service that matches with the same labels as two different versions, and then we can set, in this case, we have 4 pods running for this application, 1 for the new version, and we're going to see how that works, and then 3 to the new service. So, but it's a little bit of a tedious process. It's a little bit manual, so it's not necessarily ideal if we really want to go faster. So then there's another tool called Istio, or service mesh. So in this case, it's Istio. There's other service meshes too. But we're not going to talk about all the different solutions. We're going to talk about one use case, but keep in mind there's other service meshes as well. So with a service mesh, what's nice is that you basically have a lot more control over the services that your application is using. So you can do things with service mesh like intelligent routing and load balancing between different services. You can do, we already said we can do some sort of canary release with Kubernetes, but with Istio, with service mesh, we actually can control the traffic between services with a virtual service. We can also do things like chaos engineering. We can inject faults. We can say, hey, for this service, I want to send 20% of my traffic, I want to have it return a 500 error or something, just to see, how does that behave in real life production issues? Because ideally, you want to test that when you have control over it, and then you can see instead of when there's a when there's an outage at not 5 p.m. but 1 a.m. in the morning. If you can do chaos testing, then you can really see what your system would do if there are issues. You can do a bunch of other things with service mesh, so you can do tracing, you get telemetry, you can encrypt your traffic and all that. But we're talking about delivery today, right? So let's focus on that. So Istio works with the concept of a sidecar container. So it basically injects a container in your pod. So a pod usually is one container of your application, but actually you can have multiple containers inside a pod, and they share the same resources. So for example, the network. And so you can have you can externalize the capabilities such as the networking and so on and so forth with the service mesh, and then control it in a central control panel, which makes it quite handy for our use case of our delivery. So back to the canary releases. In this case, we're using Istio, right? And so basically we have 2 destinations. So this is an Istio virtual service. You have this concept of a destination, and then here you can see we have version v1 and version v2, and then we can set the weight. So what percentage you want to send to one version or the other. So in this case, we send 3/4 of our traffic to v1 and 25% to the other. The nice thing about this is that if I want to change it, I can do it pretty quickly. I can just adjust these parameters, and then traffic will flow accordingly to the version that I want. I can also do shadowing of my traffic with Istio. So for example, that same kind of virtual service, in this case, we can set a mirror, and then we can say, hey, mirror my traffic to version 2, and then the traffic isn't going to, the end user is not going to see that the traffic is going to version 2, but it is actually, so you can test your application under load. Then you can do things like dark canary deployments where you match with a specific, it could be a header. There's a few different ways that you can configure it, but in this case, we want in the header there needs to be an end user who matches Alexandra, and only Alexandra can test our new version, whereas everybody else goes to the previous version. So those are kind of some of the things that you can do with Istio.
So Kevin,
yes.
to this point, this is a layer 7 routing, whereas the service is layer 4 routing, right? The Kubernetes service understands only round robin and source IP. Here, you're doing a layer 7 routing based on headers, HTTP, HTTPS headers, or just round robin, or putting a weight. You're deciding your canary, your blue-green by kind of a weight. So it's layer 7.
Exactly, yeah. So the downside is that we still need to be updating files, YAMLs, to be able to say, hey, now I want a certain percentage, or maybe now I don't want just this user, I want to change it so that all traffic goes to version 2. So I need to redeploy, or I need to make manual changes in any case. Maybe there's some ways to automate it, well, including the one that we're going to show, but overall this way is better, but we're still doing things a little bit manually. So what if we could automate our progressive delivery? So automate the steps that we're doing to deploy. And so one of the projects that allows you to do that is Argo Rollouts. So there's ArgoCD that we already showed, right? That synchronizes. Argo Rollouts is another project under that same umbrella. So it's not ArgoCD, it's Argo Rollouts. But so it allows you to work with ArgoCD and then integrate with, for example, monitoring, such as a Prometheus or Datadog or whatever, and then work together with a proxy. So Istio is one, could be Nginx or Traffic or whatever, to be able to, then take control over how to roll out your feature, and then it's going to automatically update the rules for routing your traffic. So how does that work? Basically, this is, again, sorry, lots of YAML today, right? So this is a rollout, an Argo rollout definition. And as you can see here, there's a strategy that you define. And so in this case, it could be a canary, it could be a blue-green strategy. And then you have this thing called steps. And so here you can see we're defining 4 steps. So the first step is set the weight, right? Set 20% of my traffic to my my canary service, because you define a stable and a canary service. And then pause it. Pause it for a minute. We're going to see, how everything evolves, and then we're going to set our weight to 50, so split half of the traffic to our new version, and then wait again for 2 minutes, and then probably do the next step. But we define it here, and then when we release, it's just going to do that automatically. So it's going to do automatic sending of the traffic of 20% to our new version. Then it's going to wait. And then, of course, if you see issues, you can abort it and you can roll back. And so Argo Rollouts together with ArgoCD is going to automatically roll it back if you tell it, like, hey, abort, stop, this isn't working. And then we have the final step, which, I don't know, I just made up this name, but I call it Smart Progressive Delivery based on metrics. And so basically, we have our same Argo rollout, right? So I left out the top chunk there. We still have our strategy with the canary, and we add this chunk of analysis. And so with this analysis, we define a template, and we're going to go to the template, and I have to go now to the other side. In this case, we add a template with metrics. And so in this particular scenario, we define a provider, which is Prometheus, and yeah, sorry, it's not super visible, but you can get the slides afterwards or look at the source code. But basically what it's doing is looking at Prometheus, going to ping Prometheus every 30 seconds to see if there are any 500, 503, whatever response codes. And if that's the case, for more than our threshold, more than a certain percentage of the time, then Argo Rollouts is going to automatically roll back our feature. So we can release with different steps. So we can say, hey, release 20%. Look at how what kind of metrics are returning. So it could be a 500 error, it could be any kind of metric you get from Prometheus or from another monitoring service. And then based on that, Argo Rollouts is going to monitor, and if there are issues, it's going to automatically roll back, or it's going to progressively release our application. So we have a lot more confidence in how our application is rolling out. All right, and so, well, hopefully we're going to see that in a demo. So in this case, demo. In this case, we're going to do it with a different application with like little colors that are moving, so it's also fun to watch at. Yeah, it's nice to see different colors.
Has anyone the chance to win this fantastic polo?
I don't know how, but sure.
But well, I don't know, maybe.
All right. So
but we have stickers. No problem.
Yeah, there you go. So in this case, wow, this is really big. How do I make this smaller?
Control minus.
There we go. Okay. Okay. So here we have an application, and again with a customized file where we're going to do something very similar to the previous time, right? So we have our rollouts demo, and basically we're going to show different colors as it rolls out. So I can show you. Oops, I went a little too far here. So let's start this up. So in this case, we can see that it's just creating blue colors, right? So our first version is blue, and now we're going to release a new feature. Man, I need to make everything smaller here. Do you know a quick way of doing
Control
this?
minus?
No. Oh, yeah. Wow, that's weird. I tried that in the past, and it didn't work. Oh. Control plus.
Yeah.
So, okay, and it's on the good side there where everybody can see it. So that was a previous release I did, but so let's create a new release, right? So I'm going to change it to blue. No, sorry, I can't change it to blue. It's already green. All right. It's not a blue-green deployment. That's why I was like, I don't know about green, but so anyway. So let's commit our feature. Actually, let's just use VS Code to do that. So we have our customization. No, yes. And we're going to commit it and change to green.
I can tell you he is sweating right now, and he feels the pressure of
I know. I'm really sweating because it's really hot in here. All right. So I'm pushing my change, and now we can just show on ArgoCD again. So we have a different application for this. We have our application Canary app. And so we have 10 pods here. So let's see if we can make this a little smaller so it's more visible. So in this case, we have 10 versions of our application running. So we have high availability. And so we're going to release our new feature. So basically, that definition that I showed before is what I'm using, right? So with the steps and then analysis that looks for 500 errors. So in this case, let's see if it works. So I'm going to refresh. And then we're going to go here, and we can see that a new version is being rolled out, right? So it's creating 2 containers. So I don't remember exactly what I said. It was 10% of the traffic or 20. And so it's jumping around. But so there's 2 pods that are running, and we're serving traffic to those 2 pods, and then most of it to our previous version still. And so I think I set it to do the next step after 20 seconds or 30 seconds or something. So soon we'll see that more pods are going to be releasing. And here you can already see that some green squares are appearing, right? So we're gradually sending more traffic to our green version, and so we also need more pods to be able to handle that traffic of the more green pods,
boxes,
squares, yeah,
right.
Whatever. And so we're at 3. I should have set it to roll out a little faster because now it's getting kind of boring, right?
No, it's cool. I like these colors.
Yeah.
Look
anyway,
like
so
a disco.
Um, so eventually we'll see that it rolls out to all of them. Wow, this really jumps around quite a bit. So we can see, new container creating, and I think I said it at the end to be much faster. So we'll see if that's the case. If not, we can play around with it. But so what maybe we can do, and I think it'll be too late. But so this application allows me to also start injecting errors in a specific version. So as you can see here, there's a blue and a green square. I selected the green, and I said, hey, now all the new versions of our green application should return errors, and then we'll see if it actually works, because it's really a lot slower than I think it may be the network, but
the cluster is
it's
with some workload on site. Yeah, something to consider is having a local container registry that will speed up the download. In this case, we're using a remote container registry. So maybe that would also speed up the download. So
in the meantime, you can see that the green squares have a red, kind of thing around it. Wow, it really jumped around. Awesome demo. But so in this case, you can see there are errors for our green squares, and in the meantime, it already rolled back, or it's already rolling back our feature, I believe. But let's see. Sorry?
Why the blue ones disappeared as well? Because the error was only for the green ones.
Yeah. I'm not sure, to be honest, because so you can see here it was erroring out on the green ones, but now it's happy again. So I think there's something in my front-end application. Maybe I should refresh it, and we'll see what it does. But so anyway, the idea at least is that at some point our metrics that is pinging constantly, right, is going to notice like, hey, there's an error, and we're going to stop our rollout, and we're going to roll back to our blue version. So let's see.
Hey, we need your auto refresh feature also here.
Yeah, exactly. Can we have a pull request, please? That's the curse of the live demo, of course.
No, but it's great because it shows all the progressive delivery, progressive application updates.
Somehow my terminal was delayed.
I think we're going into.
So sorry, real quick, because I guess we were looking at an outdated version. It keeps jumping, but you can see here. Where are we? So here the analysis is running, and you can see it was able to see that there's an error. Now it's running again to see, is there a success or an error? And if there's an error, then it's going to say here error, and then it's going to eventually roll back. But I think because it's glitchy, it wasn't quite successful, and I think it's going to roll it out completely, which maybe it depends on the metrics that you're returning, of course. And in this case, the metrics weren't returning correctly because the application was not doing exactly what we wanted it to do. But hopefully, you got the idea.
So you can inject those metrics, the PromQL, which is the query language from Prometheus, this time series database used for metrics. So you inject the PromQL queries into the YAML file containing the Argo Rollout definition, right? So that's the thing, and how to use Argo Rollout, GitOps, and Istio, and Service Mesh for progressive delivery.
Yep. All right, so it looks like we're out of time. So final notes. So like I said before, doing advanced delivery techniques, the thing that you do need to keep, that's just a link for my Twitter where I'll paste the, where I'll post the slides. But what's important to keep in mind, of course, is when you do advanced delivery techniques and everything, I mean, there's always the state part, right? So if you're going to release a new version to production and you're sending traffic to both versions, or you're mirroring traffic, keep in mind, if they're both going to the same source and you don't have a proper way of handling that, then that could be a painful thing. But so that's also something that you need to keep in mind when you're designing an application, that it is able to handle multiple versions, and if not, you use feature flags and all that stuff. And of course, embrace GitOps. It's really really nice and powerful to be able to have a lot more control on your releases. I posted some of the links to the demos, but again, we'll share the slides and you can have all that. This guy here, he wrote a book, multiple books. One of them is the GitOps cookbook. So if you want to download it for free, there's the QR code. If not, you'll get the link in the slides.
I don't have it here with me because they haven't printed yet, so that's why. But you have the free digital copy. You just register to developers, redhat.com, a free account, there are tutorial, labs, and also free ebooks like this one. So you want to get started with Tecton, ArgoCD, containers. We start really from the beginning to the production use case with ArgoCD.
And he wrote another book.
Another book. So this is for if you want to modernize your Java application from Jakarta or Java EE models to Kubernetes and framework like Quarkus for cloud native development. There's if you download this book, there's a complete example of an e-commerce called the Cool Store app. Is an e-commerce of Red Hat Cool Store stuff, and you can move from the microservice to the containerization, then Kubernetes deployment.
And I think that's it. So you can find all these resources on developers.redhat.com. You can get a free OpenShift sandbox if you want to play around with Kubernetes, so you can have an environment there. And
if you use this QR code, you can have a free OpenShift account, which is a cloud Kubernetes account for free for developers, 30 days renewable also for free. You basically access to this Kubernetes cluster, and you have your quota, like 7 GB of RAM and 15 GB of storage. You can run the same app, you can deploy your stuff, you can export all your stuff and move your manifest to your GitOps repo. There's a nice feature called the export app. Once you develop your app with the nice OpenShift UI, you can export all the YAMLs and put on Git, and then you start your GitOps workflow. Wow, that's it. Thank you. I know we are extra time. Do you have any questions? Please.
You used to customize. I'd like to know from your point of view the difference between config map and customize, which one and why. And also, another question is about feature flags or maybe canary or any kind of deployment strategy. How about single page applications plus APIs, which obviously should be in sync sometimes? You should deploy a feature, but the feature is spread with a lot of services around. So that's are my questions.
I'll take the first one, you take the second.
yeah, I think the second one maybe we can take outside because it's kind of a big question.
Quickly on the first one. So config map is the way Kubernetes manage application properties, files, properties to your app. This is in general in Kubernetes. While customize is a tool that lets you patch manifest when you need it. So you can have also a config map and then a customization file that will patch that config map. So those are kind of two different use cases. And customize is kind of a superset that you can use to have a different YAML files. Instead of storing a different version of your YAML file, you just have a single customized file that will perform a patch. So I think those are two different use cases to your point. But most of the time you use config map for your application properties, and then you use customize to have a different version. Think about dev environment, stage environment, prod environment, no? You have different customized file for a different config map. So you want to patch only one thing, like the key of the config map or the data of the config map where your database is stored, your JDBC connection URL. So you're using customize to apply this patch at runtime, so you don't have to store a different YAML file of your config map. Just one config map and the customization file that will perform the patch.
Great, thanks.
Please.
One question regarding that tool that was some kind like a code name, but I forgot it. That was making the deployment actually. I mean, by
Yeah.
My question is, do you use that in prod, or because, for example, if you have multiple environments,
Yeah.
you do a
Yeah.
release a snapshot, maybe you want to
Yeah. Yeah.
help for prod and so on.
Yeah. Yeah. No, I totally got you. So this is for demo purpose. We just show the dev to prod, the straight to prod. But actually, ideally, you have this automation fully automated until stage. Then there's a user acceptance test or more kind of a input from outside. And the production is a manual step where you really promote your golden image with a manual input like ServiceNow, a ticket, the Jira ticket. No, so the pipeline will open this ticket. Then a release manager will hit the button, and this will perform the action that will really update the manifest and then send to production. So that was just for demo purpose, but to show, moving from 4 months recycle cycle to weeks, hours, minutes, even second, but the process needs to be consistent, and I'm totally with you for production, really. We need some kind of more review mode, right?
Yeah, unless you have a really good process of doing automated tests and have everything automated, and you have a lot of coverage, and you have steps of when there are new features that need to be deployed, use feature flags, and then you could automate the whole thing and go straight to production. There's some companies that do that, but yeah, it takes a lot of maturity before that.
But the rollback could be fully automated. Yeah. Think about you deploy something wrong, right? You need to roll back. Then ArgoCD can roll back from the previous commit. So we'll redeploy everything at the previous commit state. So it's really easy to roll back, roll forward with the tool, just following the Git hash.
Yeah, with ArgoCD or with the new Argo rollout?
ArgoCD. ArgoCD in general. Then Argo Rollout perform a more granular it also
That's
Argo
what defines
rollout.
the steps.
Yeah. You can be more granular in defining the steps, but in general, it's the GitOps controller that can perform this action. Welcome.
Any more questions?
Thank you very much, folks. We have stickers. Don't go away. We have stickers for you. Thank you.